In Part C, we're asked to use the ratio test to find the interval of convergence for the Taylor series found in Part B. And I've listed f of x, the function definition, and the infinite series from Part B. To find the interval of convergence, we're going to use the ratio test, which says the limit as n approaches infinity of the n plus first term, or absolute value thereof. Now, 2n as an exponent when n is n plus 1 is not going to give us 2n plus 1, it's going to give us 2 times the quantity n plus 1, which will be 2n plus 2 over n plus 1 is n plus 2 factorial. We're going to divide that, or flip and multiply, by the nth term, which is n plus 1 factorial over absolute value x minus 1 to the 2n. We simplify that. Limit as n approaches infinity, we get n plus 1 factorial over n plus 2 factorial. And you should be aware that n plus 2 factorial is just n plus 1 factorial times n plus 2, and absolute value of x minus 1 to the 2n plus 2 over x minus 1 to the 2n is going to result in, first of all, for the factorials, the n plus 1 factorials will cancel, and we'll have limit as n approaches infinity of n plus 2 in the denominator, no longer factorial, and x minus 1 to the second power, and no need for absolute value there since that's squared. So that limit is going to be 0, because as n grows infinitely large, the denominator is going to grow without bound, and the numerator for any finite value of x will be fixed. And so that will be less than 1 for all x. And so interval of convergence is negative infinity to positive infinity. And we're done with this second part.